Now this illustration deals with using other procedures to determine the ampacity of conductors due to derating, due to adjustment factors. And notice, I'm kind of surprised that many times talking to engineers and electricians that's new to our business, they don't realize that these tables in the back of the code book and the Appendix B can be used where the authority having jurisdiction goes along with it. I'd always get that done, but notice if it meets your need to adjust these ampacities according to the Appendix B, notice we are referred back here to these tables when we review 310.15. But now let's look at applying the 50% load diversity. And if you don't mind, let's just look at that part of it together. And we have a question. What is the allowable ampacity of 16 number 12 AWG THHN copper conductors with diversity located in the same raceway? Now notice you're only going to load these conductors, half of them. Now table 310.16 says, all right, number 12 conductors in the 90-degree column is 30 amps. Now we go to the table B.310.14B.2.11. And then notice 16 conductors is 70% adjustment factor if you only load half of them. So 70% of 30 amps from step 1 is 21 amp. So if we load any of those 16 conductors, only 8 of them at one time, we can put them on a 20 amp device and load. But you can only load half of them. So, and that's what the solution is saying, that we could only load 8 of them at 21 amps. And we would have to have a design so the other 8 could not come in while 8 are being energized and supplying power. Now, we apply the 50% load diversity to double check this with the question, what is the allowable ampacity of each conductor when applying this 50% diversity? Well, again, looking at our table, B310.14B.2.11 and section B.7 little a, we compare these together and we have the watts is the current squared times the resistance, which is always 1 using this concept, times the number of conductors times 50%. So watts is equal, when we take the square root of 30 times 1 times 16 conductors, loading only 50% of them, 7,200 watt. Step 2, the amps is equal to the watts divided by the number of conductors and the square root, as you see listed there. So 7,200 divided by 16 is 450. Take the square root of that, 21.2. So you can see that the table just dropped 0.2 and stayed with 21 in the solution above. So our solution here would be 21.2 amps, but the 0.2 amps has been dropped in the quick calc at the very top of the illustration, applying the 50% load diversity. Now let's look at where we're going to load more than just 8. And the question is, what is the allowable ampacity of 16 number 12 THHN copper conductors with that diversity located in the same raceway? Now, notice what we're doing here. We're loading 12 of the 16 We're not loading them all as you see here. So coming in to do that, table 310.16, number 12 is good for 30. We have 16 amps, 50%, loading only half. Let me make that clear. 15 amps. So the lab passive 16 conductors, loading them all at one time would be 15 amps. You can only put it on a 15 amp device, not 20. So this shows applying diversity factors along with derating factors where you're not applying the 50% rule to half of the conductors, but to all the conductors, and that's what figure 8-16 is illustrating. Now we'll move to the next illustration.